Hi, and welcome to our live webinar. I'm Bengt Are, and I will be your host as we will conduct a live furnace test, which is a tolerance test. We're going to demonstrate the Firebreather technology, and we will be using our cavity barrier as an example. I will come back to what the tolerance test is soon, but joining me today is Frank, who will be assisting operator of the furnace. Frode Reze, our CEO, will come and tell us more about Securo's business. Trond Røtvold, our sales manager, will be joining us and giving us an insight of core benefits of the products. And Ola Øyvind, our CTO, who would guide us through the technical details of today's test. So, what do we use this furnace for? We use this both to perform pre-testing for certification and experimental test in-house, but it can also speed up innovation for us. It can also benefit our customers who needs to verify fire performance of their own system, and of course, also new partnerships such as OEM. But what do Securo offer? We provide a passive fire-safe ventilation solution, such as facade vent, air transfer grill, cavity barrier, etc. Highlighting how this solution works and the technology behind it, starting with an in-depth look of the test process itself. Frode is here, and he will come and tell us more about Securo business. And Frode, please join us here. Could you give us a quick introduction of who is Securo?
Yeah, Securo is a Norwegian company which is specializing in passive fire protection solutions, especially for ventilations. Openings like eaves vents for air transfer grills, facades with the cavity barriers. We do develop and manufacture those products here. We are also part of the SWT group, which is a European leading group in passive fire protection, which have a lot of expertise and divisions which can help us with raw materials, manufacturing, and so on. So we can benefit from an international group here in Norway to manufacture and develop the best products within the passive fire protection business.
Right. How does Securo contribute to more sustainable environment? Could you tell us more about that?
Sustainability is very important for us. We are always, as a production company, looked into that. As a result of that, we are an Eco Lighthouse certified company, which is equivalent to ISO 14001 ISO standards, which is sustainability. And on top of that, we also have environmental product declarations on all our products, EPDs, which gives all our customers a transparency of from birth to cradle of the products.
Just to end this up, where do we sell our products? Do we only sell it here in Norway, or do we sell it worldwide? Or
our core market is Scandinavia, but we do sell throughout the world. We do. So we started in Scandinavia, Norway, Sweden, Denmark, and then we moved on to Europe, and now we're expanding outside of Europe. Our last employee was in the Emirates, in Dubai. So we are expanding our products. So our customers all around the world see the benefit of our products.
Because we're doing a test here, so that also means that we can benefit from those markets. If there are, let's say, somebody in the Middle East are going to do a new system, they could contact us and do, let's say, a pre-testing or something like that.
Yeah, a lot of our partners do need to test their systems in some way. And as we will see today, there is a test of tolerances and details about the products around our product also. So the systems need to be tested. And that can differ from market to market, but we always go into collaboration with our partners or customers to find the best solution for their system. Yeah.
Good. Thank you, Frode, for your insight. And we will move over to the furnace, and let's see what Ola Øyvind is doing. Ole,
Hi.
can you show us what we are prepared for today's test?
Sure.
Which component or product samples are about to test in the furnace?
Yeah, so we're testing a cavity barrier. We're testing the 50 mil, which is our biggest cavity barrier, and a representative supporting construction. It's a gypsum lined supporting construction and a wooden kind of supporting construction to keep it all stable. So
Right.
the exposed components here are going to be gypsum and the cavity barrier itself. We've got end seals of rock wool, which is what we recommend, because even now when we make this, we have some issues making it perfectly aligned. But the rock wool can compensate for small deviations or differences in the construction. So it's a nice way of sealing it.
Right.
So yeah.
Yeah, because we are calling it a tolerance test. What's
Yeah.
different that from a standard fire test, or is it just why do we do it?
So in terms of what we're going to be doing with the furnace, it's going to be the same as a standard fire test.
Right.
But the goal of this test today is to find out if the tolerances between the mesh and the intumescent are okay. And this is something we have to make sure fits for all variations of intumescent that we have.
Right.
Because their expansion rate, how quickly they expand, how much they expand, it all depends. There's a lot of complicated chemistry involved. So the goal here is to see consistent results.
Right.
Yeah.
Well, then I think we can go ahead and start the test if you're ready.
Yeah. Litt lenger dit. Er du klar? Ja. Starte. Tenkte du tar mot kamera? Litt lyst på trøkk. Kjøring på termostaten. Den på den. Ja. Merker at røyken kommer fra andre plasser.
Ole,
Ja.
what do we need to focus in the start of the test? I see you running around here looking What are you looking for? Is it something that is critical now that we need to be aware of?
We are very interested to see how quickly the product closes in the beginning. These are ventilating products. So in their normal state, air will pass through and they will allow water as well to drain past the product. When it becomes exposed to heat, it will expand and close off the cavity. How quickly that happens is very interesting to us, and how consistently it happens across the length of the product as well. So we're trying to keep an eye on how quickly we see that closure, we see that drop in temperature, and a telltale sign is the smoke.
Yeah. Tell us more about the smoke. There's a lot of smoke now. Is it warm? Is it cold? Why does the smoke come?
As this expands, the intumescent is releasing some chemical components that kind of visualizes like this. So as the test goes on, this will die down when everything closes up, and we'll see more smoke leakages on the other sides of the furnace. Because on the bottom side of this construction now, there's gypsum, there's some fire mastic, and there are some components that are charring and making this smoke.
Right.
Yeah, so it's not just from the product, it's also from the construction overall.
Right.
Because the heat load is quite significant. What's the temperature inside the furnace now?
Bottom chamber, we are at 560 degrees Celsius.
560?
And above 580 underneath the specimens.
Yeah.
580, yeah.
And now it's cooled down. So all the temperatures are below the threshold values that we need to stay within. So we've got closure in 3 minutes or so, 3.5, 4. Yeah.
And that, would you say, is quite expected, or at least what we hope for?
Yeah, absolutely.
Yeah. Right. Yeah.
So most likely the rest of this test is not going to be all that eventful.
Right.
We see the closure. Temperatures across the board are coming down nicely. So not to jump to any conclusions, but it looks good.
Yeah.
Seems like this particular tolerance is within the limits of what we would expect.
Yeah. Let's talk a little more about the temperatures.
Yep.
Let's say, why do we have these temperature measures? And now, of course, I'm going to talk more about test standards. So we are today testing a cavity barrier, right?
That's correct.
And today's normal standard test for cavity barrier is?
So the test that's published now is EN 1364 part 6.
Right.
It's very similar to the linear joint seal standard 1366 part 4. Same kind of limit values for integrity and for insulation. The main difference is that this is a test method made for open state products, while linear joint seal is designed for products that are closed in the beginning. Right. You can imagine that most fire testing is not for products that would have an opening in the early stage and then close.
No.
To draw a similarity, you could think about fire dampeners, both mechanical and non-mechanical. They also have a certain period of time before they are closed. And that creates some challenges. Keeping the pressure inside the furnace when you have a big hole or an opening that closes suddenly, it's a challenge to be sure. And we've been through test facilities across Europe where they've had issues because of open state products closing and their systems not really handling that transition period.
Because when we were talking about the temperature, what we are measuring, but also what is the, let's say, a normal or max temperature that you will have in a furnace like this?
All right, so typically inside the furnace, the exposure temperature is going to level out at around 1,000 degrees Celsius. That'll take us about an hour to get there. It's an exponential curve, so rises quickly and then it flattens out. On the non-exposed side, we're looking for two things with our products. We're looking for any flames. That will be a failure of integrity, meaning how long the product can prevent a fire from spreading to the other side. So you can look for visual flames, or we can test with a cotton pad and see if that ignites. The second part is temperatures, which is insulation. So what you see here are 3 thermocouplers, plate-type thermocouplers.
Yeah.
So our instrumentation and setup is based on the base standard for furnace testing,
Right.
EN 1363 Part
Yeah.
1. That's where all of the test methods spring from. So these 3 thermocouplers gives us limit values for temperature.
Yep.
And in this case, that's a delta of 180 Kelvin. So our ambient temperature plus 180 is our limit.
Yeah.
If we pass that, it's over.
Yeah. And of course, then we're talking about what also says in the standards, right? So
That's from
Yeah.
the standards, that's
Yeah.
correct. But again, fire resistance can mean many things.
Yeah.
Some people talk about fire resistance and they really only speak about integrity,
Right.
meaning they don't care about the temperatures.
Yeah.
For us, we've historically always spoken about fire resistance as both integrity and insulation in one.
short and EI for those
EI.
who don't know, right?
We would
Yeah.
say a 60-minute fire rating is EI 60.
Yeah.
But in practice, a product like this could be E
Yep.
90 or 120, but I 60,
Right.
for instance.
Yeah.
But yeah,
But if you are building a system, let's say a facade where we use normally this product, our cavity barrier, and you have a EI 60 rated cavity barrier, then the system around it should also,
I mean, yeah,
of course,
the system is never better than kind of the sum of all its parts.
Right.
If you have one 30-minute rated part of it, that will fail first, and the rest of the system is no longer able to function as it should.
Yeah.
But it's a complex thing because small changes in thickness or material density can have an impact on these figures.
Yeah.
Yeah.
I think we'll talk more about that soon, but now I will head over to our sales manager. Trond, welcome to you. You are the sales manager here at Securo. Trude talked about who Securo is. Could you tell us more about the core benefits of our product and what and where do we use these products?
For sure. One of the major advantages with the Firebreather technology is the instant fire stop. And that means that we are fire safe from the first second when a fire breaks out. And we will never let flames, heat, or embers pass into the construction at all times. So we will always protect the protected side, to say it that way. And that is often not having instant fire stop is often a major challenge with other open state solutions where they are not protecting the building in the early stages of a fire. I can demonstrate how this instant fire stop works.
Yeah, please do. I can hold the mic if you want to.
Thank you. So this is the open state cavity barriers that we have. And with this mesh, we are having instant fire stop until the intermittent strip has expanded and sealed up for the construction. And we can see when the fire hits the mesh, it will stop the fire from entering into the building or into the construction.
But why
Like
is
this.
this? Why don't the flame go through right away?
It's something to do with the geometry of the surface of the mesh.
Right.
But it's stainless steel metal, so it will absorb the heat for a certain amount of time until the metal is so hot that it will go through. But then the period has been long enough that the intumescent has expanded and closed off for further fire spread.
Right. Yeah, because that's the core thing, isn't it? Firebreather technology is in the core is generally stainless steel and intumescent, right?
Yes,
Yeah.
it's a very simple construction,
Yeah.
but it works.
Yeah.
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 And one of the other advantages that we have is that all the products are 100% passive and without any moving parts. And that means that it's a lot less chance that something is broken. And the products are always maintenance free for the lifespan of the products.
Yep.
Yeah.
Right.
And all the products are lightweighted, they're easy to work with. It's a very fast and easy installation. So that means that the total cost of installation is really low with our products.
Yeah, because I think that is a key point, especially when we talk not least about the cavity barrier, right, is that it is easy to install. You just put it up into the facade and a couple of 2-3 screws per meter or something like that, and yeah.
So compared to a lot of other solutions, the installation time is really short. And
Right.
that, as I said, will make the total cost of installation really low.
Yeah.
All the products are tested according to EN, ASTM, and UK test standards. So they are thoroughly tested and verified. And we do also have third-party approvals for all our products. And several times per year, we have factory audits. And that makes sure that all the products are verified by external experts. And it also assures that we have a high quality on all our products, the raw materials, and the production.
Right.
So you can say by using the Firebreather technology, you can always be assured that you have the best and safest solutions on the market.
Good to hear. Before we end this, could you just quickly tell us where do we use the different products?
Yes, it might be easiest if I show you on this screen where we have the open state cavity barriers.
Which we are testing today.
Yes, that's the one that you are looking at
Yeah.
inside here. That is open state cavity barrier to be used in ventilated facade constructions. We have the eaves vent that are used in the eaves or the soffit of a building to keep fire from spreading into the attic. And then we have the air transfer grill that are used for ventilation through fire-rated walls. And we have a special product on the bottom here that is produced by the largest window producers in Norway that also keeps ventilation through fire-rated walls and in the facade. It's not a product that we produce ourselves, so we are only producing the fire-safe part of the product.
Just to jump back to the air transfer grill, can we use this product both for internal and external walls?
Yes.
Yeah.
Yes, we can.
How can we do that? Is it because we? This is a leading question for sure, but because we tested with lures, right?
Yeah, it's different kind of lures that are
Yeah.
used on the inside walls and external walls.
Yeah.
That means that the lures that we use on external walls can also be used internally.
Right. Yep. Thank you, Trond, for your insights. We appreciate
Thank
it. And I think we'll go back to Ole Øyvind and see how the test is running. Okay, I just clip this to you.
Tar et bilde av motoren, ja. Eller av trafoen.
So, Ole, we are about midway in the test.
Yeah, I should
think.
say. We are 17 and a half minutes in.
And is it going still as expected?
Yeah, the temperature increase from ambient on the surface of the cavity barrier is about 60 degrees Kelvin.
Right.
55, 60 is the worst performer actually.
Right.
Inside the furnace we are at 760,
Right. Wow.
and yeah,
Yep.
we've still got a ways to go, but for a 30-minute test we're not going to reach 1,000 degrees.
That's right. Yep. I think we're going to talk just shortly a little more about the technical regarding the furnace itself. because for those who might have been to our web pages, we write that we using the ISO 834 standard fire curve.
Yep.
What in practical does that mean?
The ISO curve is this one, the 834, is the standard fire curve. Basically, it tells us what the temperature inside the furnace should be as time progresses. So you can see that on the monitor here to the left, we have the curve. In this case, it's been going for a few minutes. So there are two graphs here, but they should overlap. That's the curve being plotted and the actual temperature being logged as well. So the 834 fire curve is supposed to represent a fire inside of a room, so a fully developed room fire. Now, a room fire will typically have a cooling period when all of the material is burnt, everything is combusted.
Right.
But the 834 curve doesn't have that. It just keeps going.
Okay.
So you can do this testing for three hours if you want to, but I think you're going to struggle to find a room that will stay burning for
Right.
3 hours.
Yep. I think so too.
So yeah, that's why it kind of levels out at about 1,000, 1,200 degrees, even if you push 2 hours, 2.5 hours.
Yeah, right. Of course, I don't think you could just click on eBay and then buy a furnace like this. I see that there's a brand there, DBI.
Yeah.
Yeah.
So that's the Danish Research Institute, or Fire Research Institute, I should say. They are the supplier. They built this furnace for us. We went to them and did a few tests, checked it out, and decided that we wanted to invest in it. So this is a solution that they offer, and they can customize it to your needs. In our case, for instance, we have more thermocouplers than standard, because when we're testing air transfer grills in particular, we need more thermocouplers. We need a ton of thermocouplers.
Right.
And we will also be installing a tilting mechanism to this furnace in the very near future.
Yeah, because now we're testing horizontal and you
Yeah.
can do it vertical as right.
At the moment, we can only offer horizontal testing, but
Yeah.
we need vertical testing as well, because many of our products are installed in a vertical construction.
Yeah.
It's the same principle, same fire exposure. Yeah, and they can also play around with what kind of pressure control you need. For us, we have a pressure control system that seems capable of doing 50 Pascal.
Yeah.
For most tests, 20 Pascal is the limit that we target.
Right.
Again, coming back to the EN 1363
Yep.
Part 1 method.
When I started this webinar, I just briefly talked about the benefits of having a furnace like this, especially in-house. But of course, for your part, as also there's the responsible man for R&D, this was quite a huge step for us to take to have this furnace. And
Yeah, I mean, we could do all sorts of ad hoc testing here.
yeah,
But the experience was that even though we saw good results when we used conventional propane fires, when we go to furnace testing, it's a different beast.
yeah,
It is really a different challenge than ad hoc testing with other fuel sources.
yeah, right.
This is a severe fire load.
Yeah,
It's tough.
yeah,
Any small weaknesses, any interface issues you have, this will find them and they will fail your product. So yeah, it's been a game changer for us having it here, being able to make changes to development products and test them, see what works, see what doesn't.
yeah. Of course, and then you have also automatic log to use for.
This will
Comparisons.
create a test report that
Yeah.
shows all of the data that we've collected and the tolerance limits to be able to say that the test is okay.
Yeah, right. Yeah.
Temperature is within specs, pressures are within specs, all of that good stuff.
Now we talked about the in-house testing, and I think you know where I'm going with the next question is, can we help other companies do testing?
I mean, the furnace is here.
Yeah, yeah, yeah.
So of course, I mean, we were able to make any sort of supporting construction that you might want. This can be useful for testing insulation products, wall constructions, cable penetrations, pipe penetrations, linear joint seals. And if you're a consultant working with materials or products that you don't really know if will work, if it's a new setup, a new collection of parts, then this can give you some valuable data at a relatively low cost. Yeah.
Yep.
It's inexpensive and it's easy and it's very quick to do. We can do about 8 tests a day. It takes 20 minutes to cool down the furnace, and then we can go again.
right. That's good. Yep.
Kjøring. Hva er den her? Ja, det er 50-50. Ja.
Men på overblikkskamera så jeg 180 på kantene mot Rockfall.
Ja, mot kantene. Den her kikker jo litt igjen. Ja. And that's one thing to note as well. We are often playing around with thermal imaging,
Yep.
but the standard specifies that you use plate-type thermocouples
Yeah,
of
right.
a certain type.
Yeah.
One issue with thermal imaging, at least this kind of stuff, is that it can look through things, right?
Yep.
So if you see the steel mesh here, then when we try to measure the temperature of the steel at the top, the thermal imaging actually sees all the way down to
Yep.
the intumescent down there.
Wow. Yeah.
But that's not really an interface that's available for us.
Right.
Right.
Yeah. I see that you're using 3 thermocouples here because that also comes back to what the test standard says, right?
Absolutely.
Yeah.
It depends on the length of the specimen that you're testing, and it also depends on specifics of the standard.
Yeah.
So in this case, the placement of the thermocouplers needs to be in the center and at 2/3.
Yep.
To really be in line with the standard, we'd also want to have a splice or a joint placed somewhere along this this product, but not for these types of tests. It's not really relevant.
But we're talking about in the future that we are going to have the opportunity to tilt it, so
Yep.
we're going can do our vertical test, and of course when because we also have air transfer grills, then we need to use a little more than 3 thermocouplets, right?
That's true.
Yeah.
So for air transfer grills, the kind of minimum requirement of the standard is 15.
Wow. Yeah.
Regardless of how big or how small.
Ah.
So even the smallest grill we make, which is 100 by 100, I think, we need to place 15.
So you have more than 3 thermocouples
I do.
available. Yeah,
We've
that's
got
good.
quite a few of them, and we've
Yeah.
got a capacity for 15. So we don't have the 15 needed, but we can take away the ones we know that never fail.
Yeah.
Right.
Good.
Yeah.
Let's say because now we are soon to be in the end of the test. I think it's about 5 minutes left or something like that.
Sounds. Yep.
It seems quite stable. The temperature curve and everything looks like I would be quite confident now that we will be able to pass it. But could something unexpectedly occur?
Of course, that's always a risk. That's why we have prepped ourselves in case something goes wrong. We've got extinguishing equipment. We're wearing clothes that are flame inhibiting as well, and we've got protection gear for it.
Yeah.
So we've had incidents with fire propagating on the outside of the supporting construction, and then we have to terminate and get everything out.
Yeah.
So it can happen. It's always a risk with fire testing. So you need to be prepared and have the protection equipment in place
Yeah.
before the issue happens.
Yeah, right. Yeah, of course.
Every time we do a test, we base it on the fact that things can and will go wrong.
Yeah, and of course it's like you said. We have our product, and then you have to use supporting construction around it, and of course that also makes weak points. And
Yeah, and that's the thing. Like if we have a project where somebody wants to use a material that's never been tested before, this allows us to quickly collect data and compare it with the results we have from known supporting constructions,
Yep.
like gypsum, wood, fiber cement. Yeah, there's a lot of tests.
Frank, you're the operator today, and can you just quickly talk about what is your job here and what you need to watch and follow up on?
So first of all, I'm involved in building the samples and preparing the oven. So we have to preheat before testing, and then during the tests, of course, we have to monitor all the values, that all values are plausible, and then that we are within the limits, and of course that we don't have any fire occurring. So even if our temperature is great, somebody has to be here physically to just observe that we don't have any leakage or flames or structural failure, so that we can interact and intervene if something should go wrong. And yeah, so as long as tests go like this one, where we have low temperatures on the outside and no visible flames or damages, it's quite relaxed. But we have had cases, as Uwe mentioned, where we had to intervene and start extinguishing. So, but yeah, we are prepared for that. Yep.
Thank you.
Yeah. And it should be mentioned that the fuel source here
Yeah, we could
is
do that.
electricity.
Yeah, right.
That is the biggest difference between the furnaces that are specified in 1363 Part 1 and what we've got. You're supposed to use gas
Yeah,
or oil
Yeah.
as your fuel source.
yeah,
Using electricity is a lot easier.
Yep.
It has a ton of benefits, but strictly speaking, that's a break from the requirements of the standard.
yeah.
Yeah.
Right.
But of course, for us, it means that if we want to shut the furnace off, it's the flip of a switch, everything dies down.
Yeah.
The heating elements are off, and the risk associated with additional heat is gone.
Yeah, for sure. And there's of course a lot more other hazards with using, let's say, gas or other.
There are a ton of things to consider. Absolutely. Yeah. So the way the furnace is built up is it's divided into two parts. That's what you're seeing here. Is the separation line between the top chamber and the bottom chamber.
Yeah.
That's the key that allows us to do many tests every day. We put in a insulating plate. It's calcium silicate board in the furnace, allowing us to cool down the top part while keeping the heat in the bottom. So that when we start a new test, we have immediate heat exposure from the hot bottom chamber, and then we can regulate the temperature to ensure that we match the curve as time goes on.
Yeah.
Okay, 30 minutes have passed. The temperature on the non-exposed side, the surface up here, is now at 50 degrees Kelvin. So we can add another 16 from the ambient. And inside of the furnace, in the top chamber, to be precise, very close to the specimen itself, we've got 840. And in the bottom chamber, more or less the same values.
So then the question comes up: did we pass the tolerance test?
The tolerance test absolutely passed. And looking at this, I think we could in theory push it another 30 minutes to see what happens. But the construction we've made for you today is a 30-minute construction. Things can go wrong if we try to push it too far. So I think we will terminate the test now. But yeah.
Yeah, but I hope that everybody that is watching sees that this could also be an opportunity for possible parties out there who are about to develop a new systems, and also see that we are hands-on when we're talking about R&D and also testing our products regularly and doing tolerance tests, etc.
Yeah. From my perspective, it's like it's a low-hanging fruit to come and collect some data about your solution, about your proposal. And one thing is the data we're collecting in that particular instance, but being able to compare it to pre-accepted solutions or solutions with a known performance can give clients the confidence they need to choose something different and not carry the risks all on their own.
Yeah, good.
All right.
Then I think you
Let's
could
wrap it
just do your job and wrap it up.
Skal du ha den? Ja, det øyeblikk. Skal du ha den?
Now that the test is done, and for anyone watching who wants to dive deeper into Firebreather technology and explore our full site of fire solutions, be sure to check out our webpage, or you can contact us, of course, directly. Thanks again to Ole Eivind, Frank Frode Resve, and Trond Rødvold for an excellent demonstration. And thank you all to you who are watching for joining us today. I hope you found this webinar and test interesting and informative. And stay tuned for further updates on Firebreather technology.